Hello everyone. In this video, we will go through the statistics worksheet of the BA2 plus calculator in finding the linear regression line of a given data set. To input the data value, we activate the data worksheet by pressing second and then the number 7, the data worksheet. For linear regression problems, the data appears in pairs. The first observation, we have x1 and y1. The second observation, x2 and y2, etc. The x value is entered as xnn, and the y value is entered as ynn, where nn is the number of the current data. Then, to get the linear regression line, we activate the statistics worksheet by pressing the second key and then the number 8. We are doing linear regression, so we will use the LIN function. To get to the LIN function, we can simply press the second and the button set to choose among these methods. So here the calculator is already in LIN. Suppose not, then we press second and then set repeatedly until we get to LIN. For the LIN function, we press the down arrow and then we get a series of the calculated quantity. So we have seen these quantities in the previous video. The sample size n, the mean of the x values, x bar, the sample standard deviation of x, population standard deviation of x, the sum of x values, and the sum of x squared values. We also have the corresponding descriptive statistics for the y values. The mean of y, the sample standard deviation of y, population standard deviation of y, sum of y values, sum of y squared values. And we also have the summation of the product xy. To obtain the linear regression equation, the y-intercept of the regression line is denoted as a in the calculator, and the slope of the regression line is denoted as b. So the regression line is y hat equals a plus bx. Once we get the regression line, we can obtain the correlation coefficient r, and we can also perform prediction. Given the value of x, we can predict the y value or vice versa. Let's take a look at the first example. With the following data set, determine the equation of the regression line, and then make prediction when x equals 8.5, compute the predicted value of y, and when y equals 4.5, compute the predicted value of x. Let's key in the data. Activate the data worksheet by pressing second, and then data, DATA, the number 7. Clear previous work if necessary by pressing the second key and then clear work. We can start to key in the first observation. The x value is 4.5 and the corresponding y value is 3.2. So we key in 4.5 for x01, press enter, press the down arrow key, and key in 3.2 for the variable y01 in the calculator, press enter. And then we can press the down arrow key to key in the next observation, 6.25 and 2.6 respectively. So key in 6.25 for x02 and then 2.6 for Y02. Not to forget to press the Enter key every time you finish the input of a variable. And then observation number 3, 9.75 and 3.8 respectively. And then we can key in the rest of the data set. X04 is 10. The corresponding Y value is 5.3. The last observation, 12 and 5.5. Once we enter all the data values, we can quit the data worksheet by pressing second and then quit. Activate the statistics worksheet by pressing second and then the number 8. Press second and then set repeatedly until LIN is displayed. And we can get the necessary information by pressing the down arrow key. The sample size is 5. We keep on pressing the down arrow key until we reach the variable A and B for the regression line. Here we get A equals 1.03, and then B is 0.3582. Correlation coefficient 0.85. From that, we can already get the regression line. The regression line is 1.034882 plus 0.358249 times x. This is the first part of the question. We need to make prediction. When x equals 8.5, press the down arrow key again. X prime, we key in the value 8.5, and then press enter. And then press the down arrow key. Y prime, the predicted value of y. We need to compute this variable, so we click CPT. And we get the predicted value of y is 4.08. This is the value, the predicted value when x equals 8.5. The second part, predict the value of x when y is 4.5. So here we get to y prime, enter 4.5 for this variable, 4.5, and then press enter. Get back to the predicted value of x prime by pressing the up arrow key. Press CPT, and we get the answer. When y is 4.5, the predicted value of x is 9.672368. And you can use the regression line to verify the answer. Let's take a look at the next example. A marketing analyst for a retail company wants to predict the monthly sales revenue of a product based on its advertising spending. The analyst collects data from a sample of 7 product campaigns and records both the advertising expenditure and the corresponding monthly sales revenue as follows. Determine the equation of the regression line and forecast the monthly sales revenue for a new product campaign with an advertising budget of $2,650. Note that the unit in the table corresponds to $1,000. First, determine the equation of the regression line. Enter the data value. Activate the data worksheet. Clear previous work if necessary. And we start to key in the data. 1.6. And the corresponding Y value is 34. And then the next observation, 1.9 and 37. The third observation, 1.9 and 38. And we keep on doing this for the rest of the data set. Remember to press Enter after you input the necessary information for each variable. The last one, 2.8 and 70. Then we can quit the data worksheet and activate the statistics worksheet. Get to the LIN function and then press the down arrow key to the regression line variable A and B. A is negative 17.49, B is 30.88, and we can also get the correlation coefficient R on 0.9623. From that, we get the regression line, A plus B times X. The second part, forecast the monthly sales revenue when the advertising budget is $2,650. Press the down arrow key to get to X prime. The data is entered as in $1,000. So here we enter X as 2.65. Press Enter. And then press the down arrow key to get to the predicted value of Y. Click the CPT button. The display shows 64.35. This is in $1,000. So the predicted monthly sales revenue is $64,351.92. That's it for today's video. Thank you for watching and see you in the next video.